Alrighty, this video isn't going to be particularly exciting, but it needs to be done. What I'm going to do is I want to stub out our game store. I want to put in fake data, and I want to do all of the operations. And I want to handle the operations and have them kind of just be like this, where we just say the operation succeeded at all times. But before we do that, we have to put together all the actions. So we're going to have to write a bunch of actions and a bunch of constants. And I'm going to do that inside of the server shared actions folder, because these will be used both by the client and the server. So let's go ahead and get started. We have 5 actions to write. There are 5 things that the client can tell the server is there's 5 things the client can do to the server in the context of the game. So we'll start with export const game set options equals game set options with an export const game set options factory that takes an options and does type game set options followed by options. Next, export const game start equals game start. Export const game start equals, this takes no parameters, so we're simply going to return type of game start. Next, export const game select card equals game select card. Export const game select card. So this is when you select a card as a player. It'll take in a card ID. Actually, it'll take in a game ID and a card ID. I actually realized I need to add game ID to all of these as well. My mistake. Let's go ahead and do game select card with a game ID and a card ID. Let's go ahead and add game ID as parameters to game set options and game start. So I'm going to do game ID. It's always going to be the first parameter. In addition to adding them to the parameters, remember to add them to the events as well so that they are indeed added to that action object. Then export const game select stack. So game select stack is what happens when the cards are selects a stack as a winner. So export const game select stack equals game ID stack ID type of game ID, or whoops, type of game select stack and game ID and stack ID. And then finally, export const game send message equals game send message. Export const game send message equals game ID message goes into type of game send message, game ID, and message. Okay, those are our actions. Now we have to put together some constants. So I'm going to separate this out into another section. Whoa, I don't know what happened there. I'm going to set this up as a different section. And it's simply going to be game constants. And the first set of constants we need is the game can be in a variety of different steps at any given time. So we need to constify. I don't know if that's a word. Probably isn't C++, with its constness. When you add const keywords and weird things happen and your code breaks. But anyway, we're going to go ahead and constify the different steps that a game can be in. So this should be pretty self-explanatory. Export const step setup equals step setup. Next, export const step choose whites equals step choose whites. So this is the primary mode of the game. Export const step judge stacks equals step judge stacks. Export const step wait, if we're in a timer, it'll be in step wait. And then finally, export const step disposed equals step disposed, and that's when the game gets destroyed for whatever reason. Next up, we need to have some wait states that will tell what's going on. What are we waiting for? Because every time a round ends, we're going to have to wait for 5 seconds so we can see the winner of the winning stack, and then it'll move on to the next round. Or if the game ends, or if the game ends because there's too few players, or the game finished, or whatever, we need to be able to figure that out. So I'm going to do 2 sets of constants. One is going to be wait game over equals wait game over, and then export const wait round over equals wait round over. So that's the basic round type, or wait type. Did the game end or did the round end? Next up, we're going to do export const wait underscore reason game finished equals wait reason. Oh, come on, stop this madness. Wait reason game finished. Export const wait reason too few players. If too many people leave and the game can't continue, we want to be able to notify everyone that the game is finished. Wait reason czar left. This is if you're in the judging stack step and the czar just leaves the game. Obviously, you need to go to the next round or make the game over or whatever. And then finally, export const wait reason round finished. Wait reason round finished. So that means that the round ended normally. All right, so take a look at all those constants. I know it's not the most fun, glamorous thing to do to write all of these constants out. There are ways to write constants a little bit faster. I also could write a factory method to help me write these action factory methods, but I'm not going to worry about it. I like to have all of these exported out explicitly because then they're easier to use, but it does require a little bit of typing up front. But, you know, whatever, stuff and things. Sometimes you got to write out a bunch of constants, and that's just what you do. So now what we're going to do is we're going to stub out our game store. So take one last look at this. Now we're going to jump into client stores game. Now I'm going to start off by, what am I going to start off doing? I'm going to start off by importing observable and behavior subject up at the top. I always, you might notice, I always import observable first, then say from RxJS, then do a comma, then do behavior subject. The reason I do that is sometimes I can't spell behavior very quickly or very well. I don't know why. It's just the word is weird. Like seriously, like if you're doing Unity development, you have mono behavior everywhere and it drives me insane. Anyway, if I have the from RxJS, you'll notice I get IntelliSense, and for me, IntelliSense is just a lifesaver because I simply cannot spell. So anyway, so now we have observable and behavior subject. Next up, what I'm going to do is I'm going to create two default objects. And these objects, we'll start off with const default view. We talked about views earlier, but we never really got into them. We'll talk more about what views are later when we build the server. Just note that the default view is the state of the game the default view contains all the information that you need in order to render out the entirety of the game board, with the exception of the player hand. So I'm just going to put in some dummy data in here. I'm going to say ID equals 42, title equals, I don't know, Nelson's game. Step is going to be a step, and we'll start with step setup. That'll be the first step anyway. Options is going to be an object with a score limit of, I don't know, 5, and sets of 1 ED. And then players is going to be an array, and each player is going to have a handful of bits of data. An ID, let's do with 1, a name, a score, a is czar, a is playing, and an is winner. So every single player will have this information. So we'll just create a couple dummy players, 2, 3, 4, blah, whoa, stuff. Then we will have a round object, which will be null for now. And the round object is going to contain the information about the round, such as what's the black card and what stacks are available and so on. And then we'll have a timer, which we'll set to null. The timer is going to be when we're on the step wait. The timer will indicate how long the timer is going to go for and the reason why it's waited. Anyway, so this is how the game is going to look in a scenario where we have 4 dummy players. We're in the setup state, we have no round, and we have some basic options. Now let's do our default player state. Remember, all this information is going to be sent in by the server eventually. We're just putting in dummy data so we can hook into it and write our React components first. Now the player state is going to be a little bit more interesting. Because the player state is going to be just each player will have their own player state, and it'll give them information about things that only they can see. It's their kind of private view into the world. So that things like everybody's hand is never sent to any other player besides the player that is responsible for it. So the player state is going to contain all the information that the players array contains, such as ID, let's do ID of 1, name of Nelson, score of 0, is czar false, is playing false, is winner false. Actually, now that I'm thinking about it, I'm going to make a change here. I'm not going to repeat this data. Instead, I'm just going to have our ID of 1, and then in that way, he'll be able to look up in the players array. I mean, I don't know why I didn't realize that before. It adds a little bit more code, but it saves on data and potentially performance. However, what will definitely be in the player state is the hand and the stack. So the hand is going to contain an array of cards of what you have currently in your hand. The stack is going to be information about your currently played stack. So you play a card onto your own stack, and then you'll be able to know those cards. But you won't be able to see anybody else's cards until everybody is played. But you will be able to see your own. That's why your stack is going to be part of your player state. Or your player view, rather. Okay. So now what we're going to do is we're just going to go straight down the constructor. The first thing we're going to do is we're going to hook up all of our new actions, and we're just going to have them automatically succeed. So we're going to do a game set options. Action goes into dispatcher succeed action. And I'm just going to copy and paste this, let's see, 1, 2, 3, 4 times. Because it's going to be the same implementation for everything. And then we'll do game start for the next one, game select card for the next one, game select stack for the next one, and then finally game send message for the last one. So for now, we're just saying, okay, you're automatically successful. However, in the future, we will have a socket dispatch here where we send that action to the server. All right, let's do our view. I'm going to say this view money equals, I'm just going to do new behavior subject and pass in default view. Then this player money equals new behavior subject player view, or default player state. Whoops, I did player state. Why did I do that? I meant default player view. So I just renamed my default player state to default player view. Not entirely sure why that was different, but stuff and things. Okay, make sure you have all that. Next up, let's do our ops. And this isn't a particularly glamorous thing, but we're actually going to implement them in their entirety. We're not going to fake these out. So I'm going to go ahead. We have create game. We have join game. Then we're going to have op set options equals money map op dispatcher on a dot game set options followed by is logged in money. So we can only set the options if we're logged in. Now, in the future, you might want to say, okay, there's a concept of the owner of the game. Currently, there won't be a concept of an owner. Everyone can set options. Everyone can click the start button. But maybe you want to make it so there's a concept of an owner. So maybe in your can here, instead of just saying if you're logged in, you would say if you're logged in and your player ID is the same ID as the owner ID. And that's something you can add. That would be an interesting feature and pretty easy to add. Next up, we will do op start, which will be basically the same thing. So map op money, and we're going to say dispatcher on money a game start, and we'll make sure we're logged in. Next up, I'm going to do something similar to what I did with is logged in. Actually, I'm going to move is logged in. You don't have to do this, but I'm going to move it to right before we use it. Because I'm going to do something similar down here. I'm going to say const player and game money equals observable dot combine latest this view money, this player money. So what I'm doing is I have this player and game observable that's going to produce both the view and the player whenever either of these change. And we'll be able to use this for some more advanced permissions as far as can you do this particular thing. So I'm going to say this op select card money equals map op. We're going to pass in dispatcher on money a dot select card, and then we'll say player and game dot map. Now the syntax is going to look a little funky. We're going to open up parentheses, then we're going to open up brackets, and we're going to do game and player, and then we're going to open up a anonymous function and say game.step equals a step choose whites. And the next thing we want to make sure is that we're currently playing. So what we need to do is we need to find our current player out of the players based off our player view ID and determine if the is playing is true or not. So that's actually going to require a little bit more code. As a result, I'm going to break this out into its own multi-line setup here. And I'm going to say const rPlayer, and I'm going to use Lodash, which we don't have imported, I don't believe yet, but we will in a moment. I'm going to say Lodash find game.players ID is player ID. And then I'm going to say return rPlayer and game.step equals a step choose whites and rPlayer is playing. So the combined latest will return an array, and we're using array deconstruction here to grab the game and the player. So the first one will be this observable, the second will be that observable. And then we simply locate our player, and we determine if we're currently playing in the round and the game is on step choose whites. Now before I implement our last two operations, I'm going to import Lodash at the top. So I'm going to say import underscore from Lodash. All right, so make sure you do that. And if you don't, ESLint will helpfully remind you. Now I'm going to copy and paste this so I don't have to write this out again, but I'm going to change, obviously, a few things. Instead of op select card, it's going to be op select stack. Instead of a.gameSelectCard, it's going to be a.gameSelectStack. Then for our player, I'm going to do, instead of a step choose whites, it's going to be a step judge stacks. Instead of our player is playing, it'll be our player is czar. So just make all those changes, and that will say you can only perform this operation if we're on the judge stack step and you are the czar. Finally, I'm going to do op send message money equals map op dispatcher on money a dot send game send message followed by is logged in money, and that's it. So definitely on my op send message here, I could go ahead do the same thing I did with the lobby and validate it, but I'm not going to worry about that. You guys, as an exercise to you guys can take the same sort of way we validated the message before we submitted it and apply it here, but I don't care. And that's it. We have our ops, we have our dummy actions, and we're good to go. So I'm going to scroll through this file one more time. Definitely check out the default view, because that is the data we're going to use in our views in order to render the game. And then we have our ops. And really, that's about it for the stores. Obviously, we have to go in and hook the stores up to Socket.io at some point, once we have the server going. But this is the structure of the stores. This is how we're going to interact with the stores. And I think this pretty much wraps up this video. In the next video, we will start on the actual game components. Now that we have all this data available, this dummy data available, we can start building our components. And with that, we will see you guys in the next video.